Question 18. Okay, we have a graph here, and the question says find the limit of this function as x approaches to -5. It's very important to see -5 from the left. So first of all, this is -5. From the left, it means that we are approaching to x to -5 from this side. So it means that you can ignore the rest of the graph. You don't need to see that. And now, as the values of x gets closer to -5, the values of y, you see, these guys get closer to this value, which is 2. If it was, what is the value of the function as x goes to -5 positive? In that case, you should have used this other one, which will give you 4. So let me just write it here just as an extra fact here, which is not related to this question. No. Okay. Any question, any comments here?
Yeah, I have a question.
Yes, go ahead, please.
And what should we do if it doesn't say from which side is it approaching?
Oh, I see. That's a good question. So if it doesn't say from which side, in this case at least, you go and look at the function from both sides. So you find the limit of x as x approaches to -5 from the left. You find limit of the function as x approaches to -5 from the right. So in this case, these are what, 2 and 4. And then if they are equal, then the limit is equal to that number. If they are not equal, which is the case, then the limit f of x as x goes to -5 without saying from which side, this limit does not exist.
Thank you.
You're welcome. Any other question, any comments? Okay, then that means that I can go to question 19. Says find the value of the function as x, find the limit of the function as x goes to 2. Okay, when we are finding the limit of the function, we ignore the value of the function. So just ignore that whatever happening at 2. We want to study what is happening when we go to 2 from the right or from the left. As we get closer to this guy from the right, you see, these values are getting closer to 1. So in other words, why do I use the limit of f of x as x approaches to 2 from the right is equal to 1. And when we get closer to 2 from the left, you see, as I get closer, I'm getting closer this way, and the values of y getting closer down there to what function? Oh, to 1 again. So limit of f of x as x approaches to 2 minus is still 1. Since these two are equal, then that means the limit of the function as x approaches to 2 is equal to 1.
I have a question.
Sure, go ahead, please.
I thought you said in the past question that like the point is also supposed to equal.
No, I didn't say that. I said, okay, let's go back. I said if 2 limits, not the value, if the 2 limits, left and right, you see, I didn't talk about the value of the function.
Oh, okay.
If you're bringing the value of the function, you're considering continuity, not the limit.
Okay.
Okay, does that make sense?
Uh-huh.
Okay, perfect. And any other question for this one, 19? Okay, nice. Question 20. Oh, I didn't copy it completely. Oh, no. Actually, it goes back to question 20. That's the same function. So let me just copy that, bring it here. Copy, and then go to question 20. And then oh, paste, very nice. Okay, so we have the same function. The question is, at which value the function is differentiable? Remember that if f is differentiable at a point at x equal to a, then it is going to be continuous at a. It means what? It means that if there is a point at which the function is not continuous, then the function is not going to be differentiable there. So then the question is, what points, at what points the function is discontinuous? So remember, for the discontinuity, first you need to make sure that f is defined at that point. Then you have to make sure that the limit at that point as x approaches to a exists. And then these two must be equal to each other. Okay, so that is the definition of continuity. Now, here, one by one we go. At 2, the value of the function, you should find the solid bullet there. It is equal to 3. Limit of the function, we actually did in the previous question. It is equal to 1. These two are not equal. That means that f is discontinuous at x equal to 2. So that is the first thing we have there. The second point, at -5, yes, we know that at x equal to -5, f of -5 is equal to 4. How about the limit? Well, we discussed that before. As x goes to -5, not from the left, not from the right, the limit itself, this does not exist. Since it does not exist, that means that f is discontinuous at x equal to -5. Okay. Is there any other point that I have to study its continuity? X equal to 0. You see, for x equal to 0, there is no value for function. F is not defined at x equal to 0. So that means that f is not continuous at that point, or it is discontinuous at that point. Very nice. So we found all the points at which the function is discontinuous. There is also one more point, this point here. You see, if the function has corner the graph has a corner in a point, that means that this is not differentiable at that point. So f is not differentiable at x equal to -7. So 3 points from there, 3 points from there, 1 point here, and we have to find all of them. The rest is okay.